Okay, so here are two full examples. We'll work them one at a time of related rates problems. It says car A is going west at 50 miles per hour and car B is going north at 60 miles per hour. Both are headed for the intersection of the two roads. At what rate are the cars approaching each other when car A is 0.3 miles and car B is 0.4 miles from the intersection? So the first thing you probably want to do is draw a picture. So I'm going to draw a picture of two roads that are intersecting. And I'm going to put the cars on it. They're both headed towards the intersection. Car A is going west. We're going to do north, south, west, east. So car A is headed west towards the intersection. So I'm going to say this is where car A is. And it's headed that way. Car B is headed north. So he's below. This is car B, and he's headed that way. So both are headed for the intersection of the two roads. At what rate are the cars approaching each other when car A is 0.3 miles and car B is 0.4 miles from the intersection? So I'm going to put a list of knowns and unknowns here. I'm going to call this distance obviously A and this distance B. So A is 0.3 miles. B is 0.4 miles. They also told me dA dt and dB dt. Okay, so dA dt, car A is going 50 miles per hour. dB dt, car B is going 60 miles per hour. And you might think that that's all they told you, but they actually told you more than that. And it really depends on how you think about the problem here, but if you'll notice where car A is to the right, so it has a positive value. So I'm going to put a little plus here to show that I've thought about it. Car B is below, so I'm going to call this my origin and say that car B is really, it's a negative value because it's below. Now look at dA dt. We're headed to the left. To the left, I'm going to give it a negative velocity. And dB dt is headed up, car B is headed up, so this will have a positive. And you always want to think about the signs of what you do here. All right, so we want to know at what rate are the cars approaching each other. And when you get a math problem like this, they're literally talking about how is the distance between the cars changing, and that is not shown on the picture. So the distance between the cars would be shown with a line connecting the two cars. We want to know how fast is that line decreasing in size. So what you need is some equation that relates all of your variables together, and it should be fairly obvious that in this case we have the Pythagorean theorem. So I'm going to be very clever and call this side C. So my Pythagorean theorem is a squared plus b squared equals c squared. Now when I take the derivative of it with respect to t, I will have the rates related as well. So the derivative of a squared is 2a dA dt. The derivative of b squared is 2b dB dt. And the derivative of c squared is 2c dC dt. So the next thing you might notice when you see this is that there's a 2 in every single term. So you can actually just divide both sides by 2 and get rid of them, or you can leave them there. I'm going to go ahead and leave them there for right now and fill in the information I know and see what I still need. So my equation says I'll have 2 times my a value. I'm going to bring it down here where I have more room. So 2 times 0.3 times my dA dt, negative 50, plus 2 times my b value, a negative 0.4, times my dB dt, which is 60, equals 2 times the c value, aha, I need something, times dC dt, and that is what I'm actually looking for. So you might think that you're missing a variable, but if you come back to the equation that relates them, you have a way to find that variable. It's using the Pythagorean theorem. I know that b is 0.4 in size, a is 0.3 in size. This is a 3, 4, 5 right triangle, so c will be 0.5. If you don't catch it, you can just do the Pythagorean theorem. So using your calculator, or solving for dC dt is really easy, but 2 times 0.3 times a negative 50 equals a negative 30 And then this will be negative as well. So 2 times a negative 0.4 times 60 equals a negative 48 equals 2 times 0.5, which is 1 dc dt. And this is a negative 78 dc dt. It's negative because this distance is decreasing. So that makes sense that it's a negative, and you do need units on. So this would be miles. C would be measured in miles, so miles per hour. So it says, at what rate are the cars approaching each other? At a rate of 78 miles per hour. And I'll do the next problem in the next video.